guys to change this and put it around some of these categories on both customer service. I'm supposed to judge customer service and get through that presentation. It's hard to judge that online, so you gotta look at it.
Good afternoon. My name is Cody Akins. Joining me here are Claudio Arellano and Wayne Chang. We are the acoustic-based automatic texture analyzer team. Current method to test texture for snack products require a panel of trained experts to take already produced sample, taste it, and when they're experts, quantify the texture of that product. Unfortunately, that TDS is both expensive, it's extremely tedious, and it doesn't provide any kind of real-time feedback in a process control system that allows the snack product manufacturers, such as Frito-Lay, to control their processes based on the texture of the snack products that they're producing. Therefore, the goal for our project was to build a machine that could repeatedly characterize the texture attributes of a snack product in real time as it comes off the manufacturing line. This is done using the acoustic characteristic that is generated by the crushing event by placing chips into a compression chamber and crushing them down, listening to the acoustic signal, performing some signal processing, and then generating a texture response that is associated with that sound. Some of the requirements for our project were that it needs to be reconfigurable for new snack products. This means that some of the mechanics of the design have to be able to be taken off very easily and replaced with different pieces, and also that the algorithm has to be adaptable and that you can add in different kinds of responses. Another one was that we couldn't use any custom electronic components. Since this is something that is used on the industry floor, it's something that needs to be easily maintained by more of electricians than electrical engineers. It was important that we use things that were easily replaceable in real time. Another one was that all exposed components must be caustic washdown safe. Since this machine will be subject to the same sanitary conditions as any other food-grade device, all of our electrical components had to be able to withstand a caustic washdown sanitation process. Our design uses three major components. There's a preprocessor that takes a full-size sample and steps it down into smaller pieces that are better for the acoustic algorithm to process. Then they move into the main assembly where the ball screw actuator actually crushes the sample, and we have two high-precision microphones that listen to that event. That signal is captured by our National Instruments compact radio, which takes that signal in, does signal processing, and outputs texture values to our user interface, which is a touch panel computer. The results of our project were ultimately that we were able to program every piece of the system. We have a working user interface and a working compact radio controller, which required FPGA programming. Unfortunately, the motors for our project were a bit undersized, and that provided some major roadblocks here at the end. However, we did everything we could to overcome that, and I encourage you to come by our booth and see our texture analysis process. Thank you.
Any questions? When you were making little chips out of big chips, is that a manual operation or is it automated off the line?
It is automated, yes. Well, it will require user input. They'll have to actually put the chips into a hopper on the machine. However, there's a stepper motor on the back side there, and you can see that on our actual device, that moves these crushing teeth, and it forces the chips past the shearing blades that crush the chips automatically, which is actually a big improvement. When we were doing research at PepsiCo at the beginning of this project, you had to crush the chips through a sieve by hand, which when you're trying to get, this size chips and then, a tube this big takes a long time. So this automatic process is a big improvement.
So out of the two pieces of equipment there, did you design, develop, and build this from scratch?
We did, yeah, absolutely. We actually have three mechanical engineers that also work on our team. One, Joe Portella, sitting right back there, and we have two others. They designed all of the mechanics custom for this machine. So everything you see on our device on our booth is custom made.
What's the budget for these building all these?
We can't give you an exact number. I can say it is significantly higher than your typical senior design project. Anytime you have, a National Instruments compact radio by itself is many thousands of dollars. And then we have quite a few custom fabricated stainless steel pieces. So stainless steel by itself is
So did you actually get some data that correlates your acoustic to tasting?
We did, absolutely. And actually, PepsiCo had done some research prior to this project to basically validate that proof of concept with a different setup that used a few different pieces shoved together, and ours was to kind of combine that process. And we were able to crush a chip and using their model, see what that texture result matches what it should be.
Is there a software member of your team? Or who did
We all three designed the software. Wayne did most of the user interface programming. I did all the motion control code, and Claudio performed most of the signal processing. Entire things were in LabVIEW, user interface, and FPGA. And
Time for one last question.
Yeah, so for the acoustic data you collected, how much is from the mechanics itself and how much is from
Sure, yeah, that was definitely a significant portion of the design. So Claudio wrote some pretty intelligent noise canceling software that was able to, for example, we know the speed of the motors, so we can cancel out that frequency to an extent. And the other thing is, before the piston actually hits the chips, there's a little bit of time there that we can listen to that signal, and we have a good idea of what the characteristic of the machine is without the chip event, the chip crushing event. We can use that to kind of set a noise floor to cancel that noise out.
Thanks.
All right, thank you.